The figure consists of an equilateral triangle, a square, and a regular pentagon. It is built by sticks of equal length. At most, many such figures can be built with a big box of 12 sticks of equal length. So we have to find how many figures we can build with 12 sticks. Let's go step by step. First, we have an equilateral triangle with sticks 3 used. We have a square with sticks 4 used. We have a pentagon with sticks 5 used. So how many total we use? 3 plus 4 plus 5 gives us 12. But wait, we have 2 sticks in common. So we take out 2 from here and it becomes 10. So we need 10 sticks to build this figure. Now we have to find out how many figures we can make using 12 sticks. So we divide 12 by 10. What do we get? We get 201 and 2 as remainder. Since we cannot use 2 sticks, we will be having 201 figures we can make using 12 sticks. Our answer is option D. Problem 18. Gregor forms 2 numbers with the digit 1, 2, 3, 4, 5 and 6. Both numbers have 3 digits and each digit is used only once. Gregor adds these 2 numbers. What is the greatest sum Gregor can obtain? So let's do it step by step. When we talk about numbers and we have to solve a problem, we distribute in terms of 100, units and 10. So we have 3 digits number. So we said 100, units and tens. Since we are adding 2 numbers, we want the largest digit in the largest place values, that is hundreds. So we write 6 in here and then we have another digit, so we use the largest number there. So we say 5. Then we move on with the little lowest number, that is 4, and then we make it 3, then we mark it 2 and we make it 1. So this is the largest 2 3-digit numbers we will get. 1, 2, 3, 4, 5 and 6. Now let's sum it. So we say total is 2 plus 1, 3, 4 plus 3, 7 and 6 plus 5, 11. So our number is 1173, which is our option A. Problem 19. Laura, Iggy, Wall and Kate want to be in one photo together. Kate and Laura are best friends and they want to stand next to each other. Iggy wants to stand next to Laura because he likes her. In how many possible ways can they arrange for the photo? These are our options. Let's go over this again carefully in the simplest way possible. Kate and Laura are best friends and they want to stand next to each other. Iggy wants to stand next to Laura because he likes her. Wall does not have any special request. This means Kate, Laura, and Iggy are stuck together as one group and Val as separate. So let's say Kate, Laura, Iggy. They form a group, a close bound group together. Val is a single person. So there are 2 ways we can place this group. We can place Kate, Laura, Iggy, or you can say Iggy, Laura, Kate, because Laura and Kate don't want to be together. So they form another group together. Now we have Wall. So Wall can be arranged here. We can arrange here, we can arrange here, we can arrange here. So we can arrange Wall in 4 different ways. So our answer is option B, 4. Problem 20. A grasshopper wants to climb a staircase with many steps. She can make only two kinds of jump, 3 steps up or 4 steps down. Beginning at the ground level, at least how many jumps will she have to make in order to take a rest on the 22nd step? These are our options. She can jump up to 3 steps or jump 4 steps down. She starts at 0 and needs to land exactly on 22nd step. She wants to use the fewest jumps possible. Let's go step by step. So these are our steps. Grasshopper jumps 3 steps. So we gave 1, 2, 3, 4, 5, 6, and 7. So we grasshopper jump 7 steps. Now jump down 4 steps. So 1, 2, 3, 4, 17. So we are using trial and error. We jump up and down till we reach and rest at 22nd step. So we have stepped down 4 and reached 17. That means we did 1 jump. Now jump up 3 steps. So 18, 19, 20. Jump 1. Now jump down 4 steps. So 19, 18, 17, 16. So we reached at 16. We jump 1 more. Jump up 3 steps now. So 17, 18, 19, and 20, 21, 22. And we reached our destination, 22nd step. And we did 2 jumps, 17, 18, 19, and 20, 21, 22. So how many total is here? 7, 8, 9, 10, 11, 12. So a grasshopper jumps 12 steps to reach to 22nd step. So our answer is option D, 12. Problem 21. Frank made a domino snack of 7 tiles. He put the tiles next to each other so that the sides with the same number of dots touch. Originally, the snake had 33 dots on its back. However, Frank's brother George took away 2 tiles from the snake. See the picture. How many dots were in the place with the question mark? So we have to find it out. How many dots are there on this question mark? These are our options. Let's count the tiles. So we have here 1. We have nothing here. We counted 0. We mark it as 5. This is 5. This is 3, 3, 2. So since it touches the same tile, so it will be 2 as well. We have 2 in here, we have 1, and we will have 1 as it says that the same number of dots touched each other. Now we have to determine this tile, the dots on this tile. So let's count this. 1 plus 5, 6, 6 plus 5, 11, 11 plus 3, 14, 14 plus 3, 17, 17 plus 2, 19, 19 plus 2, 21, 22, 23, and 25. So we have 25 in total. Now, how many dots are there? 33 total dots. So we say 33 minus 25 gives us 8 dots left. Since there are 2 tiles, we distribute 8 in 2 tiles, which is like divided by 2 gives us 4. So the dots on this tile where the question mark is 4. And here it is 4. So our answer is option C, 4. Problem 22. A special clock has 3 hands of different lengths for hours, for minutes, and for seconds. We do not know which hand is which, but we do know that the clock runs correctly. At 12:55:30 p.m., the hands were in the position depicted on the right. How will this clock look like at 8:11:00 p.m.? So we don't know the hands, but we have been given the time. So based on the time, we can determine what these hands are. So it says 12. So it's before that. So that is an hour 55 is minute, and 30 is second. Now we have to determine what is 8:11:00 p.m. So we look at option A. We see that hour is at 8, seconds is 00, and minutes is 11. So this is our answer, option A. But let's try other options as well. So we have here 8, minutes is 00, and this is around 11. So we have 8:00 and 11. This one says we have 1:40 and 00. So it is 1:40:00. We have option D. We have 12. Minute is at 11 and second is at 40. Option E. We have hour is at 11. Minute is 40 and second is 11. So our answer is option A. That is when it is 8:11:11:00 happens. Problem 23. A rectangular paper sheet measures 192 into 84 mm. You cut the sheets along just one straight line to get two parts, one of which is a square. Then you do the same with the non-square part of the sheet and so on. What is the length of the side of the smallest square you can get with this procedure? These are our options. Let's go step by step. So we have a rectangular paper sheet, measures 192 into 84 mm. Now we cut the sheet along just one straight line to get to two parts. So we cut along this part, square and non-square. So the side of this square is 84. So the length from here to here is 192 minus 84 gives us 108 and 84. Now we cut the non-square again. So we remove the square out of it and let's have just the non-square. Now we cut it into two pieces, a square and a non-square. So we take out 84 as a square in here. The side length is 84. So 108 minus 84 gives us 24 and 84. Now we again remove the square from it and have measure non-square. So the length of a non-square is now 24, 84, 24, 84. Now we cut it into two pieces. So we cut from here and take out a 24 square. Now it becomes 24 and this is 24 as well. And this one is 84 minus 24 gives us 60. So 60 and 24. The side length is 60 and 24. Now we remove the square from it. So it becomes 24, 60, 60, 24. Now again we cut a square and a non-square. So we cut a square of length 24. So 24, the side of this is 24. This is 24. So 60 minus 24 gives us 36. So we have 24, 36. Again we remove a square and then we'll cut the non-square. So we have 36, 24, 36, 24. Now we cut it into two, 24 square. Now the side size is 24 here. So 36 minus 24 gives us 24 and 12. Now we remove the square, 24, 24 square out of it. We have 24, 12, 24, 12. Again we cut it into two pieces. So we cut it into 12. Now we have this size is 12. So 24 minus 12 gives us 12, 12, 12. Now our question says, what is the length of the side of the smallest square you can get with this procedure? So the smallest square we get is 12 mm. So answer is option E, 12 mm. Problem 24. In a soccer game, the winner gains 3 points while the loser gains 0 points. If the game is a draw, then the two teams gain 1 point each. A team has played 38 games and gained 80 points. Find the greatest possible number of games that the team lost. These are our options. Let's go step by step and find the correct answer in a simple way. The team played 38 games in total. The team gains 80 points. They could have won, lost, or drawn. So the win is 3 points, draw is 1 point, loss is 0 points. Now find the closest multiple of 3 to 80. So the closest multiple of 3 is 78. This means that we have 78 wins from the 80. The question says the greatest possible number of games. So we will go with the maximum wins, 78. Now how many games they have won? So we divide by 3 and we get 26 wins. Now we find the remaining points. So we had 80 points. We have used 78 for winning. So how many left? So 80 minus 78 gives us 2 points left. So we add 2 points to the 26 wins and gets us total games played so far is 26 plus 2, 28 games. So we have winning, we have draws, the 2 points draw, and then now we have to find the lost games. So we have 38 games in total. So 26 plus 2 we got 28 games. Win plus draw gives us 28 games. So how many left? 38 minus 28 gives us 10. So we have 10 lost games. And our answer is option C, 10. This wraps up the last problem of part C from 2012 Math Kangaroo for grade 3 and 4. Great job following along. We'll see you in the next adventure. Stay tuned and keep practicing. Thank you.